So now you have to determine basically what the two outputs are going to be, or the threshold levels. That's basically what we have to do with this. During the lesson, I went through a demonstration. I'm going to do it one more time. Make sure we are solid. Notice how I normally go positive, negative, half cycle, analyze it, but look what it is. We're going to do negative first, positive here. Because the answer is going to be the same, isn't it? It's going to be the same thing. It doesn't matter which one you choose to do first. Negative half cycle, positive half cycle, doesn't matter. The answer is still going to be the same. But don't get God or confused if you're asked on the negative half cycle or during the negative half cycle. Holy crap, don't freak out. Do exactly what I'm about to show you one more time. And this will be easy. So we'll look at this one first. 4.2 volt Zener. Hey, it doesn't matter what it is. I just pulled the number out my arse. It's using what kind of feedback? Negative or degenerate feedback, okay. And we have to determine the output threshold, or the two outputs of this thing during the positive, negative half cycle. So here's our positive half cycle. What's the first thing I told you to do, or step one during the lesson? What's the first thing you need to do? Yeah, because it's a two-part process. Bring that positive down here, because I have two paths. I have two paths here. Here, here. Step one, invert the signal. So I'm going to put step one right there. So inverting input's always going to take the input and do what to it? Flip it over, 180-degree phase shift, if you will. So take that positive half cycle, make it a negative. A negative what? Well, now we need to apply that positive potential to the cathode of the Zener. And remember anything about BeO3, what's that Zener diode going to do? Or what's this going to cause to happen here? Okay. Because I'm placing a more positive potential on the N-type material. Don't forget that part here. And I'm telling you, drawing pictures may help you. You just got to remember that, oh yeah, NP material, all that cool stuff. This is going to basically what? Keep that switch open? Yes. Yeah. So I'm going to have a negative. Where did negative come from? It came from here because it's getting inverted. 4.2 volts. That's for the positive half cycle. Negative half cycle. Now we need a nominal value. Because this negative potential is going to cause that Zener to do what? You got two chances or two options, or flip a coin. It's either going to forward bias or reverse bias it.
Oh, 0.6.
Okay, and that's called what?
Forward bias.
There you go. That's the answer right there. Because I put a more negative potential on the N-type material. The Zener is primarily manufactured to operate in a reverse condition, but you can forward bias it. You can. Does this make sense? Okay. Who's going to do the next one? Mr. Goss. This one, what did I do? What's the difference? Yeah, I just flipped the dot around. Now the anode is more toward the input. So now we're going to look at the negative half cycle first. Ready, go. Explain. Explain yourself.
The first thing you have to do is you have to flip the signal. So negative becomes positive.
Uh-huh.
And then it flows to the P-type material. And it comes out as the 4.2.
Okay. Yeah, it keeps it reverse bias, yeah. So, does that make sense to everybody? And notice how these are different. Here we did the positive half cycle first, negative 4.2, we looked at negative, now it's positive 4.2. Okay, so who can do the positive half cycle? Well, there is. Thanks for volunteering. Ready?
Sure.
Just walk me through it. Step one.
For the positive half cycle, you're going to invert it, so
Okay.
it'll come out as a negative,
Okay?
and then it will.
Keep going. I'm putting more positive potential on P-type material, and since BU03, that concept, we always say, it's going to, I'm putting more.
It's gonna forward.
There you go. Because it must be, because we already wrote that down. So it's gonna drop the proverbial, what do we always say? Yeah, 0.6, like that, done. That's all you have to do with this. Let's label this. All right. We want to change it to Cedar.
8 volts.
Okay. Oh, man, we're getting all kinds of wicked. All right. Whose turn is it? All right. Let me draw the signal node. All right, Dan. So do the one on left first.
Well, you're gonna invert that negative signal, that's gonna come out positive.
Step one, this one. Okay? Positive something, what?
It should be a positive 8 point, no,
We're going here now, more negative on end.
so it should go through the Z diode then, since it's reverse bias. 0.6.
More negative on end. I'm gonna make that zener do what more? Or actually make it, no, not really what more. Actually make it conduct, aren't we? Yeah. Or cause it to forward bias. So, see, negative, 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 negative. This is positive because of that. So, if I forward bias it, what's it gonna be? Positive what?
0.6.
Okay, good. Yeah, go ahead and do the other one. Do the positive half cycle now.
And then you can invert that positive half cycle so it'll come out negative.
Okay? And now what?
And since it's forward bias, it'll come out 8.3 volts.
Look, this is positive potential on it now. I'm putting now P, or positive potential on N-type material.
So it'll saturate it.
Reverse bias.
Reverse bias?
Yeah. Okay. Well, you really have to know how to do this, because that is probably, yeah, we've been doing this since like BO3. So more positive potential on N-type material is going to keep that thing open, switch open, 8.3 volts. Or look at it like this, if you figured that one out, it can't be positive and negative 0.6, can it? It's either going to, during one half cycle, it's going to be forward bias, and the other half cycle is going to be reversed or drop in Cedar voltage. Those are the choices. Can't be both. Okay, you can do the next one now.
Yes.
Yeah, make sure you get this thing. All right. Let's do something really crazy. I don't know, we're living on the edge now. There you go.
Alright, so the positive half cycle is going to be inverted
To what?
to negative.
Okay.
And so since it's on the positive type of material, it'll be forward bias to 0.6 volts.
Uh-huh. Yeah, there you go. And what about the negative half cycle?
The negative half cycle will be inverted into a positive. And it will be reverse bias to 8.3 volts.
Okay. And notice they are different. The outputs are different. It matters which way the diode is configured in the circuit.